Good afternoon, all of you. We are resuming the YouTube videos again. So today's video is on chemical reactions and equations. And at the end of the video, you can solve the homework PDF, the link to which is given in the description box below. You can solve that homework PDF. It has got 10 MCQs. So you can solve it and just send your answers to me as a homework. You don't have to show the working. So in today's session, I will of course give you some concepts, some inputs about the theories which are required to solve the homework, right? Now, let's have a look at two reactions. So this is the first reaction, 4NH3 plus 5O2 equal to 4NO plus 6H2O, and there's another reaction, CH4 plus 2O2 equal to CO2 plus 2H2O. Let's see these two reactions. First of all, these two reactions, they both are redox reactions. Why? Because over here, ammonia is getting oxidized to nitric oxide and oxygen is getting reduced to water. Over here, CH4 is getting oxidized to CO2 and oxygen is getting reduced to H2O. So the first thing we can say about these two reactions is that they both are redox reactions. The second thing is you can also think of these two reactions as displacement reactions, because in this reaction oxygen is displacing hydrogen to change ammonia to nitric oxide, and here oxygen is displacing hydrogen to change CH4 to carbon dioxide. So these are the two features of these two reactions. One is that they both can be thought of as redox reactions, and the other is that you can also think of them as displacement reactions. Now let us go one step further and see one extreme example of displacement. In fact, it is actually double displacement, and also let us have a look at one extreme example of redox reaction. So first of all, I am talking about this example, Na2SO4 plus BaCl2 I am talking about this reaction, Na2SO4 plus BaCl2. This is equal to BaSO4 plus 2NaCl. Okay? Na2SO4 plus BaCl2 is BaSO4 plus 2NaCl. Now in this reaction, you can see it is double displacement reaction because barium is displacing sodium to give barium sulfate, and sodium is displacing barium to give sodium chloride. So it is called double displacement reaction. Now in this particular reaction, the barium sulfate which is obtained is insoluble. So anything which is insoluble is automatically a precipitate. So BaSO4 is a precipitate. So that is why precipitation is a specific example of double displacement. So in displacement, what happens that one atom displaces another, and in double displacement what happens, there are pairs of cations and pairs of anions which have a mutual displacement. So over here, barium displaces sodium to give BaSO4 and sodium displaces barium to give NaCl. So this is an example of double displacement. And in double displacement, if you get a precipitate, that is a specific example of double displacement, that is called precipitation reaction. Now regarding redox, I will give you one example which is frankly speaking not there in your syllabus, but it's a very interesting example. Have a look at this reaction. So KMnO4 plus FeSO4 plus H2SO4. This is giving Fe2SO4 whole thrice plus MnSO4 plus K2SO4 plus H2O. So this is an example of a redox reaction. Now why have I said that this is an extreme example of redox reaction? What is the reason? First of all, in this reaction, potassium permanganate, KMnO4 is called potassium permanganate. It is undergoing reduction, and FeSO4 is undergoing oxidation. So this is the compound which is undergoing reduction. This is the compound which is undergoing oxidation. Now why did I choose this example to tell you that this is an extreme example of redox? Because you will notice that in FeSO4 the valency of iron is 2, and in Fe2SO4 whole thrice the valency of iron is 3. So during the course of the reaction, the valency of iron is changing from 2 to 3. So remember, this is another case of oxidation if the valency increases from 2 to 3. So the valency of iron is 2, here the valency of iron is 3, so the valency is increasing from 2 to 3. So this is an example of oxidation, that the valency is increasing from 2 to 3. So that is another interesting technique to determine whether a substance is getting oxidized or not. So one way of understanding whether a substance is getting oxidized, that I have told you, and this is another way, that the valency of the atom increases from 2 to 3, that means the valency goes up, so that means it is getting oxidized. Okay, and the other thing, which I wanted to talk about in this session is exothermic processes. You see, there are a lot of famous exothermic processes, a lot of famous endothermic processes, but I think the exothermic processes which are very well known, they actually outnumber the endothermic processes, because exothermic suggests that heat is going out of the system, so that is like energy going out of the system, and energy going out, in science, energy going out is associated with stability. If energy goes out of a system, it becomes more stable. So there are a far greater number of exothermic reactions than endothermic reactions. Now exothermic, we'll just discuss a few important exothermic reactions. The very, very important number one, that is dilution of acid. Okay, this is a very, very important number one reaction, dilution of an acid. If you want to dilute an acid, remember it is a very, very exothermic reaction. So if you want to dilute an acid, you must remember that you should not add water to the acid. If you add water to the acid, then there might be splashing, and the heat that is produced and the splashing that will happen, it may actually break the container, and in fact it can be fatal to the person who is doing the operation. So remember that you should never add water to the acid, rather you should add acid to the water very, very slowly. So that is an important example of exothermic, that is dilution of an acid. Number two, reaction of water with quicklime. Okay, reaction of water with quicklime. If you react water with quicklime, that is in fact known as slaking of lime, because when you react water and quicklime, you will get slaked lime. So quicklime changes to slaked lime. So the reaction of water with lime is also known as slaking of lime. It is a highly exothermic reaction. Slaking of lime is a highly exothermic reaction. Okay, now regarding dissolution, see, dissolution means you take a substance and you dissolve it in a solvent. So when a substance dissolves in a solvent, what actually happens is that the bonds which are holding the molecules of the substance together, those bonds tend to break and new bonds are formed due to the interaction with the solvent. That is what happens. So because of the fact that new bonds are formed, most of the time dissolution is an exothermic process, but it is not highly exothermic in most cases, but it is exothermic. But there are a few examples of dissolution which are also endothermic. So we are basically focusing on exothermic, like I already told you. So we'll just see two examples. Dissolution of NaOH with H2O. You know that NaOH is highly soluble in water. So most of these compounds which are highly soluble in water, when you put them in water, you will get an exothermic reaction. Like I said, NaOH is caustic soda. It is highly caustic. If you put it in water, it will be a highly exothermic reaction. That doesn't mean that all dissolutions are highly exothermic, but most of them are exothermic. Like I said, the bonds of the original substance like NaOH, they starts wearing off and new bonds are formed due to the interaction with the solvent. So that is why most of the dissolutions are exothermic. Dissolution of anhydrous copper sulfate with water. Actually, copper sulfate is a powdery substance, which is a white powdery substance, but if you put it in water, it will dissolve to give copper sulfate dot 5H2O, which is a crystalline substance which is blue in color. So dissolution of copper sulfate in water is again an exothermic reaction because it is dissolving and new interactions are happening and you are getting a completely new substance and a new kind of substance. A powder is changing into a crystal, and that is why it is exothermic. So that more or less completes the examples of exothermic reaction, and also we had a discussion about redox and about precipitation, displacement and double displacement. That sums up whatever has to be done in this session. On that note, I'll conclude, and please do the homework. The link to the homework is given in the description box below, and it has 10 MCQs. Just do it and send your answers to me. Okay, that's it. I'll end the session. Bye all.